let's get back to the beginning. Sorry, guys. All right, here we go. All right, frames of reference and average velocity are the two things we'll look at here. First thing is frames of reference and displacement. So any measurement we take will have a position, distance, or speed must be made with respect to frame of reference. And so, for example, if you're sitting on a train and someone walks down the aisle, their speed with respect to the train is a few miles per hour at most. Their speed with respect to the ground is much higher. So what that means is, if you're on a train with someone and the train's going, let's say 50 kilometers per hour, and let's make it 100 meters per second, and then the person next to you is walking at 2 meters per second in the same direction that the train's moving. To you, on the train, the person looks like they're walking at 2 meters per second. But if there's a person that's outside the train watching the train drive by, it looks like the person's moving at 102 meters per second because it's this train plus the person. So they're seeing both. So you always got to think about where the person is looking or where you're seeing the movement from, the frame of reference. Now quickly, let's make a distinction between distance and displacement. By definition, distance is called a scalar, and a scalar is just a number with no direction. Displacement, on the other hand, is a vector, and a vector is something that has a number and a direction. So when we look at the situation on the screen, you see displacement is the blue line, is how far the object is from the starting point, regardless of how it got there. So displacement in this case would be final position minus initial position. Distance traveled is the dashed line, which means this person walked all the way here and then walked back. So the distance traveled would be how you got there. The displacement is from where you start to where you finish. And again, displacement vector has a direction, distance, scalar, no direction. So displacement, x2 minus x1. So let's say we're traveling to the right here on an x-axis. We would take 30 minus 10, which means our displacement would be 20. But let's say we're moving to the left. Now we would take 10 minus 30, which means our displacement would be negative 20 because we're going to the left. So displacement has that sign to help us designate the direction. Sign is always direction. So when you think about the math and physics, anytime you see positive or negative, it means the direction it's headed based on what you make positive or negative. So read this example and we will do it.
All right, so first problem, an ant starts at 20 centimeters, walks along the x-axis to negative 20 centimeters, then turns around and walks back to negative 10 centimeters. We want to determine displacement and total distance. So first off, we start here and we head to negative 20 and then back to here. So when we look at this, we see the total path that was traveled, right? So displacement, and just on the x, is change in x, which is x1, or x2 minus x1. And essentially, it's just x2 where we finish, so negative 10 minus 20, okay? So my displacement, negative 10 minus 20, is negative 30 centimeters. So that is my displacement. Distance is total path taken. So I walked from 20 to 20. So this is 20 to 0 to 20. So that's going to be 40 centimeters. And then I walked 10 more this way, plus 10 centimeters. So my distance traveled was 50 centimeters. Now the difference between distance and displacement always has a direction. So that's why we have our negatives and positives. But distance doesn't. Distance is just a number. It's a scalar and just tells us the one number we need to know.
Average velocity. So speed is how far an object travels in a given time interval. So speed is distance traveled over time that goes by. Since it's distance over time, speed itself, since distance is a scalar, speed is a scalar. There's no direction. There's no positive or negative number associated with speed. Velocity includes directional information, and that's where displacement over time. So it's final position minus initial position over time. Velocity can be negative because negative will show us direction. So positive and negative velocity means direction that we're traveling. Speed is a scalar, does not have a direction. Velocity is a vector. Please read this problem, and we will do it.
Okay, before we talk about velocity and speed, let's look at the equations one more time. Speed is distance over time. Velocity is displacement over time, or change in position. So where we finished minus where we started, divided by how much time has elapsed. So in this example, the position of a runner as a function of time is plotted on an x-axis of a coordinate system. During 3 seconds of time, the position changes from 50 meters to 30.5. What is the runner's average velocity? So velocity right here, displacement over time. So for this case, it would be x2, which is 30.5 minus x1, which is 50, over 3 seconds. And to do this on our calculator correctly, we got to do the top first. So we take 30.5 minus 50. We get negative 19 and a half. Divide that by 3. And we get negative 6.5. Is that 50.0? It's 50.0. So we want to have 3 sig figs. So 6.50. And our units are meters, centimeters per second. Meters per second. That would be my answer, negative 6.50 meters per second. And again, velocity is a vector, so it shows direction. So really that negative means we're probably going in that direction, which we are, because we're going from 50 to 30.5. So that's why the number's negative.
Please read this problem, and we will do it.
All right, for this example, it asks how far can a cyclist travel in 2.5 hours along a straight road if her average velocity is 18 kilometers per hour. So how far is, we want to find our displacement, right, or distance. In this case, since we're talking velocity, we're finding displacement. And we also want to make this into an equation. So our velocity is 18 kilometers per hour. That's equal to our displacement, which is the unknown, over the time frame, which is 2.5 hours. And essentially I put this over 1, x times 1 is x, and then I cross here and I go 18 kilometers per hour times 2.5 hours. Hours cancel. We just take 18 and multiply it by 2.5. And we get an answer of 45. Let me check my sig figs. Should be 2 sig figs, so 45 kilometers would be my distance taken. So just taking the equation and solving for the unknown.
Please read this problem, and we will do it.
All right, so example 2.3 talks about a car changing speed. It's traveling at a constant 50 kilometers per hour for 100 kilometers, then speeds up to 100 kilometers per hour for the next 100 kilometers of driving. What is the car's average speed for the 200 kilometer trip? So speed is distance over time. So right away we know our distance is 200 kilometers. But now we got to find time. And to find the time is we have to figure out how long the car was traveling at 50 and then how long the car was traveling at 100 kilometers per hour. And since we were looking for time, and we look at this equation, if we want to solve for time, right? So we say this, we say speed times time is equal to distance. And all I did was cross multiply to get that. To solve for time, I just divide both sides by speed, so time is distance. divided by speed. So now to find my time in each of these cases, I just take the distance divided by the speed. So for the first 100 kilometers, and I'm going to divide that by my speed, which was 50 kilometers per hour. Kilometers cancel, 100 divided by 50 is 2, so that first part of the leg of the trip took 2 hours. It's actually only one sig fig there. And then if we were traveling the next 100 kilometers, but we were traveling it at 100 kilometers per hour, 100 divided by 100 would be 1 hour. And I still think there's one sig fig there, which it is. So we combine these two, 3 hours of travel time. So 200 divided by 3, and we can find our average speed for the trip. So 200 divided by 3, and I get 66.6. It's going to be repeating kilometers per hour for my speed. It's kind of weird that we only have one sig fig here, so essentially this answer is going to be 70 kilometers per hour rounded to the one sig fig. But then again, that's how we find that. So if we have our speed changing and staying constant, we have to find time. Then we got to put it back in to find our average speed. You can't just take 100 plus 50 to get 150 divided by 2 and get 75. That would not be correct.